This is the demo for GAM Engine 3 Milestone 3. So right now I have 3 models running. The humanoid on the left is using the original animation. The one on the right is using the compressed version. There's a merging going on, and the merge of Teddy is pretty good because there isn't much movement at all. And the left one running the original animations. Yeah, the current compress ratio is close to 50%, and by exit that, there's no memory leaking. So first I look at the skeleton class. Right now the skeleton, it takes a file and it will just set hierarchy and set skin. You also have the compute bone result. I'm just going to put it here. And this set hierarchy, it will take this hierarchy data. I will use that to compute the magic table. The magic table I will show you is the Teddy one. So you see it's right here. This is going to be used in the calculations of the bone world position. And yes, this is calculated these 2D vectors, and then going to pass that to the hierarchy table. And this table is going to be stored in the SSBO, the hierarchy table, SSBO. And then there's set skin. The skin has this invert matrix buffer, which is calculated in the in the model converter, and you just take those data and just shove it into the SSBO, and this SSBO is going to pass to the graphic object skin, and it also shares the bone world matrix because, well, I have animations. This animation is going to update this. Animation is going to tell me which frame I'm in, and then I will just update this bone world matrix under here when I set animation pose, and then this bone world matrix is going to be used to calculate the skin. So let's look at the skin, the graphic object skin. It has this SSBO, and just when its calculation is going to bind this inverse matrix pose and the bone world matrix to the shader, and then you're just going to do the calculations over there, and yep. So I don't have to pass it in every single frame. It's already uploaded in the GPU. And then let's talk about animations. So right now, after set the skeleton, I was just going to add animations, like append them after it. So this Teddy, I'm using this Teddy animation. So this file actually contains 3 of it. And for this humanoid, I have these 3 animations selected. I convert them one by one, and using this, I can always keep adding more. If I want, I can add a lot of it. So yep, it will create animations, and this SSBO bone result, which is just created at the start of skeleton, is going to be passed into these animations. Actually, it's useless now because now the animation calculations will be done on the by the in the skeleton. So right now, these animations have the when I create new animations, I will pass in all this bone data, and had a pointer over here, and just going to pass that. And in this bone data, you will notice the first bone doesn't contain the frame informations. It's just going to have this first element containing the number of the index of this frame based on the converter output, because this doesn't change for the original animation, because original one use all the frames, but in compressed one I will just take out some of the frames. So how do I know which index this frame was? I'm just going to put it here, and the rest of it is just going to ignore the first bone and just keep incrementing this pointer and get all this data. and then this data is going to shove into this SSBO, this keyframe data, and store in this animation class. So you will have several animations, and when I'm updating these skeletons, I need to go to update animations, so process animations. You have this merging state, or merging state is the blending. I used to call it merging. And when I set the current animations, well, it was just going into this blending state. So what's the blending state? You just have the blend animation. I should call it the previous animations, and the current one is going to update that current one to the when I'm going to find the current one, and this merging will be true, and the T blend is going to be set to 0. And the previous animations and current animations are just going to get the current frame, which is based on the current time. I'm just going to return which frame I supposed to be in. So these two animations can be both be updating. And I will find the compute mixer shader, and well, have this SBO, which is the keyframe data stored right here. I will just bind the range and get these two, and this bone result is just going to be the one I have in the skeleton class. So after this calculation, I'm able to yes, also this TS no, not here. Yep, this is based on the blending. So the blending is going to 0 to 1, so it will have a transition fully from 0 to 1 from the previous animation to the current one. And also when it's not merging, I will have these three numbers, and I'm going to run these animations and get this process current frame. This is something I used to do all of this in the process animation compute, but now I moved all of those into the skeleton class. And this is going to tell me, well, I have the current time, so what time I should be going on now. This pre-frame time, I get rid of the frame bucket, so I'm now using this is a array of time. It's super simple. I'm just going to have that. I can just calculate it and get the K2, and when K2 is 0, it means it just start fresh over. So K1 will be the last frame. Otherwise, it will be the frame that is before the K2, and get the TS over here. So I have these three numbers ready, and the current animations. I bind the first place, I bind the second one, set the bone result, do the calculations. So this mixer takes two bone arrays and the result arrays, the TS, the bone count. I'm not sure I'm using bone count, so I'm not using bone count. So right now we're just going to do this slurp and everything. This result is going to be picked up by set animation post compute, which is going to compute every bone's word position. So now the hierarchy table will also pass over here. So in this compute shader, I have every one of them running the same similar things that is going to run through the loop of all the bones, and just whenever reach something that is greater than the is greater than the bone count, you're just going to ignore it. Otherwise, in these meaningful numbers, you're just going to calculate this one by one and go over every one of them to get the final position. Also, this root word is something I pass in when I create a skeleton. I can set the scale, rotation, and transform matrices, and this is going to be the base word matrix for all of these bones. After all these calculations, every bone will be in their positions, and yes, and this bone word matrix is updated, that would be because it's already stored in the skin, in the graphic object skin. So the skin will be use that to render the skin. And that is everything for the engine. And let's look at the animation part. So right now I have this animation converted compressed version. I have these two helper functions with arrow check. I take these vectors of bones, which is everything I have in a frame, with another frame, and go to one of it. Ignore the first one because the first one is the index of this of this frame. I'm just going to use these default functions to see if it's equal, if it's like. And this threshold I set over here is hard coded. I can right now it returns me like 50% of reductions. So if I get below looser, I will have a better compressed ratio, but it's a lot worse animation. So whenever something like exceeds the threshold, return false. And this interpolated frame is just going passing one frame, the starting frame. The frame is the target, TS, and just do the calculations and then pass it back. It's not really efficient, but it is not doing the runtime, so I'm cool with that. And then it's run through this gigantic loop because all the information I have for the animations is stored here. The D bones is external, and this 3D vector get all this informations. And so yeah, in the main I'm gonna compress. I can create an empty one, and this vectors int keep is just gonna tell me, oh, all right, in this animations, all of this frame, which index I'm going to be stored into the keep, and then after all the calculations, in the end, I will run through the keep and just push all those desired frames into the compressed animation. This calculation is just what Keenan told us. This TKP is the one I can keep. IT is iterating one, and the TG is the target. So it's set. The target was originally set like 2 steps ahead, and this whenever it reach the end of the list, I know, oh, the last one I have to store the last one in it. So I'm just going to break it and then store the last one. Otherwise, I will always like reach 2 steps ahead and see if I can use it interpolate the next frame. So I will just, this is the current kept one, and this is the target, and TS, which is the ratio, and I will just going to get the a frame, and using this frame to compare with the actual frame that's ahead of me, this iterator is standing on. So if it's not different too much, it's past check. I'm just going to keep looking at the next one. So if so whenever it's failed, well, it failed. So I'm just going to escape that, and step back will be my new keep. I will just pass that to the keep vector. Otherwise, I will just keep let's see if it's going good, going great. I'll just keep jumping, keep going ahead. This target is getting set further and further until I reach the end, or I finally hit something and break. And yeah, and that's how I pass all the keyframe inside. And because the first bone right now is going to had its first element store the number of this frame, so this will be used in the engine that tells me which frame I am at, and it's going to this time it's going to be used by it. So yep, and that's it for the demo. Great, thank you, and stay healthy.